So let's have example number 1 for equilibrium. Okay, we have here a 2,500 pound rigid bar is supported by a pin at A and a vertical rod at B as shown. The bar supports a uniform load W, and that's equal to 500 pounds per foot throughout its entire span. Compute the support reactions at A and B for equilibrium. Okay, so what we're going to do here is we're going to draw the free body diagram. So free body diagram meaning it has no supports anymore, but rather the equivalent translation of the structure. Next is we're going to translate according to problem that the bar itself has its own weight. Like the bar has a 2,500 pound weight. So meaning to say at the middle of this bar, which is 10 feet, it has its own weight here at the middle. So this is 2,500 pounds, and that's exactly 5 meters on the left side and 5 meters on the right side, because this is a rigid bar with a uniform section. So this is our point A and this is our point B. As you can see, I'm not writing the supports anymore, but rather I am supplying the translated weight for every load, including its weight. Next is we have the bar supports a uniform load. So we're going to rewrite or redraw the uniform load. So say this is our uniform load, and according to problem that the uniform load has an intensity of 500 pounds per foot. So this is the intensity. Therefore, we would be able to get its resultant. So the resultant for this load is 500 pound-feet times the total distribution, which is 10. Oh, by the way, this is not meters, but rather feet. I'm sorry. Okay, so now you have the 5 feet on both sides, and here this is 5,000 pounds. Okay, and then we're going to translate what type of reactions we would provide there, since that is a hinge. And then somehow there will be two reactions. One is the vertical and the other one is a horizontal. So for the vertical, I'm gonna call it as a vertical, and I will have an assumption to be apart. And for the horizontal, I'll just call it AH, and I'm gonna write it to the right. Okay, here at point B there is a support, and maybe that support is a rod, since it's kind of supporting a vertical downward force. So might as well, since this is a rod, this could be this is considered as a cable or a link. So this is we're going to provide along the section of the support vertical, and you have BV here, and I will have the direction to be apart. Okay, so now we have translated all the support reactions and equivalent resultants and weight for the body itself. This time we will now proceed in using the equilibrium equation. Let's start with the first equilibrium equation, summation of forces horizontal equal to 0. So we'll have to the right positive and to the left negative. So here, since we are trying to get all the horizontal forces, meaning we will only be counting, writing all the horizontal forces in the equation. So here in the illustration, we only have AH, and that is to the right, that is along the horizontal, and no more. So since wala na may lain na force aside ni AH, then you have to equate that to 0 to support equilibrium concept. Therefore, this is now our final answer for the supports. Okay, so we're through with the summation of forces vertical. Next is summation of moment. So you can interchangeably use summation of forces vertical and summation of moment. Okay, so we're done with the summation of forces horizontal. Let us proceed with summation of moment. So in getting the summation of moment equal to 0, you have to decide at which point you are going to rotate. So just a tip. So here, always rotate at the supports. Okay, so since we have two supports, that's either A and B, then somehow you have to choose which point you are going to rotate first. So I'm gonna rotate at point B. So rotating point B, this BV is eliminated from the system because BV cannot create any rotation, but rather BV will only pass through point B. So it's not going to create any rotation. So this time we are now going to calculate the forces AV, as AV is going to rotate at point B with a clockwise direction and a moment arm of 10. Next is this one, the 2500. The 2500 will rotate about point B. Since it's downward, it's going to be counterclockwise. So it's going to rotate counterclockwise about point B. So as you can see here, it's that kind of direction. So since this is vertical, downward, so therefore the rotation is like that. So it's counterclockwise. Okay, and then the moment arm would be the distance between the two forces or the 2 points. So this is the first point and this is the second point. So it's 5. Next is we have this one, the 5,000 pounds, and it's negative because it's still going to rotate about point B with a counterclockwise direction, and you multiply it with 5, for that is the moment arm, and that's equal to 0. So this time we now have AV, and it's going to be this term. You transfer all the terms except AV to the other side. So this is 2,500 times 5, then plus 5,000 times 5 over 10. So now you have AV. So here. So AV is 2,500 times 5 plus 5,000 times 5 divided by 10. So the answer is 3750 pounds. And we obtain a positive value because the assumption for our AV upward is correct. Okay, next is the last equation, since we're through with the summation of forces horizontal and summation of forces moment. So the last equation is summation of forces vertical equal to 0. So that's upward positive and that's downward negative. So what are the forces on the vertical side? So there are 4 forces. This is AV, the 2,500, the 5,000, and the BV. So we're going to solve for BV. That's why we're writing AV upward, so that's positive, plus BV, that's upward also, minus 2,500 because 2,500 is downward, and the 5,000 is also downward, so you have to write negative 5,000 equal to 0. And since you have AV already, so let us substitute AV 3750 plus BV minus 2,500 minus 5,000 equal to 0. And transpose all the terms except BV to the right side. We will have negative 3750 plus 2,500 plus 5,000. So therefore BV is, let's solve for BV. That's negative 3750 plus 2,500 plus 5,000. And that's 3750. And that's pounds. We obtain a positive value because, again, our assumption that BV is upward is correct. So that's it.